This lesson is on function families. So the first function family are linear functions. Linear functions have the equation f of x equals mx plus b, where m and b are numbers. So if we look at the equation here, we see f of x equals negative 3x plus 7. I know that that is a linear function because I have an x with a number in front of it and something being added or subtracted. In terms of the graph, a linear function is just a straight line. So that graph can be slanted in some way like it is here. It can also just be a horizontal line. A linear function cannot be a vertical line because that would not be a function because that would not pass the vertical line test. The next function family is an exponential function. An exponential function has the equation f of x equals a times b to the x power plus c, where a, b, and c are going to be numbers. So one way we can remember an exponential function is that x is the exponent. So as we can see here, our exponential function, x is the exponent, and we see it there. So if we look at our example here, we have 2 to the x power minus 1. So these ones are numbers, and our exponent is a variable, in this case x. In terms of our graph, an exponential function is a curve. And I'm going to say it's not just a curve, but it's a curve that kind of flattens out on one side. So as we can see here, this exponential function starts flat and goes up. So I'm going to say a curve that flattens out. For this slide, I accidentally wrote everything down without recording it, so I'm just going to talk about it. So quadratic function has a form f of x equals ax squared plus bx plus c, where a, b, and c are going to be numbers. The way that we can remember a quadratic function is that our x has a 2 in the exponent. So looking at our example here, we have f of x equals 2x squared plus 3x minus 1. In terms of the graph, our graph is going to be U-shaped. So that U-shape can be facing up like it is in our example, but it can also be facing down. It cannot, however, be facing to the side because, again, these are function families, which means that these have to be function. If our graph is sideways, we know that that is not a function because it does not pass the vertical line test. All right, our last function family is a linear absolute value function, and the equation has the form f of x equals a with an absolute value bar, x plus b, absolute value bar, plus c, where we can have a, b, and c be numbers. One thing to keep in mind, I'm saying that a, b, and c are numbers, but it might be the case where that number might be 0, so it might look like it's not there. So for example, if we look at our equation here, 2 with the absolute value bar is x, plus 1, but we see nothing is being added and subtracted to x, but that would just mean that b would be 0. So just because it's not there doesn't mean that it wouldn't follow this form. It could just be a 0. The way that we can remember linear absolute value function is that the equation has absolute value bars. Which look like just 2 vertical lines. So in terms of the graph, these graphs are always going to be V-shaped. So just like with quadratic functions, that V shape could be facing up, like our example here, but it could also be facing down. However, it cannot be facing to the side because, as we said, these are function families. All of these are functions. If the V would be on its side, it would not pass the vertical line test and therefore would not be a function. All right, so now I'm just going to go over a couple of the homework problems. So looking at number 4, for this particular problem set, we're classifying each function as linear function, linear absolute value function, quadratic function, or an exponential function. Explain how we know. So looking at number 4, it's an equation, and the one thing that sticks out to me is that this equation has these vertical bars, which are linear absolute value bars. So what I'm going to say that this is a linear absolute value function. because the equation has absolute value bars. Okay. Now looking at number 5, it says to identify the independent and dependent quantity in the scenario, explain how you know. A researcher has determined that there is a relationship between how many absences a student has and their grade in the class. So if you're having trouble with these, what I suggest doing is identifying the two quantities, which would be how many absences a student has and their grade in the class, and then saying, is it the absences depend on the grade, or the grade depends on the absences, and see which one makes more sense. So to me, the second one made more sense. The grade depended on the absences, which means the grade in the class would be the dependent quantity, and the absences would be the independent quantity. And to explain, I would say a student's grade depends on how many absences they have. And then one thing I might say to explain this further is when you're absent, you tend to miss assignments. You miss assignments. And your grade goes down. So for this one, I could maybe see someone arguing the other way as well. A lot of me grading this particular type of question is more dependent on how you explain it, not necessarily that your answer matches mine exactly. If your explanation makes sense, I would consider it correct as well.